Good morning, ladies and gentlemen. Our goal today is to answer this question. If you jump into the water from a diving board, will it take more or less time to hit the water if you run off rather than just step off? So we're going to be talking about motion in 2 dimensions. Let's talk about something that we know. We know that the acceleration due to gravity is a constant near Earth's surface, ignoring air resistance. Gravity pulls down, so G is always down. In this class, for AP Physics, we will always use -10 meters per second squared. Let's walk and roll. Walk and roll. What a beautiful day. So I'm dropping the ball here. Drop the ball. And where does the ball come back to? Now it loses a little bit of oomph.
Turn sideways. I can see that better if you turn sideways.
It loses a little bit of oomph because it loses energy when it hits the ground.
Yeah.
But ultimately it comes back to my hand, yes?
Would it make any difference if you were walking?
It's a good question. Let's try it out. I'm gonna walk this way. A little more space here. Okay, here we go.
Try that again.
Whoa, hit that spot there. The ground's a little crooked here.
One more time.
The ball ultimately comes back to my hand, yes?
Do that just standing still. All right.
So what's the difference here?
That's an excellent question. Let's go back in and figure it out.
So when we are moving, when we're standing still, we're only worried about one component, up and down. That's vertical, right?
Yep.
But when we're walking, now we have to think about 2 components, 2 independent perpendicular vectors. That is, the motion in one dimension is unaffected by motion in the other, as if the other didn't exist.
Okay, what does that mean?
Well, let's go take a look at what this looks like from my perspective walking. Let's go outside.
Goes down, comes back up. All right. Goes down, comes back up. Goes down, comes back up.
Okay, let's go back to what we saw before. Independence of perpendicular vectors. What does this even mean? Well, when you think about independence from your parents, you're separate from them, right? Unrelated.
They can't tell me what to do anymore.
No.
Wouldn't that be nice?
Perpendicular, we've seen that before. Perpendicular, think about it as an X and a Y, they pin that perpendicular across. And then vectors, we just got finished talking about those arrows that have magnitude and direction. So what this means is if an object motion has both vertical and horizontal components, they are independent of each other.
What does independence mean?
Oh yeah, it means that you are separate from them. They do not matter. They don't affect each other. Just like you are independent from your parents, or at least you wish you were. All right. So that is the motion. This is what independent means in physics. That is the motion of one dimension is unaffected by the motion of the other, as if they didn't exist. It's as if your parents don't even exist. Okay. So let's take a look at what this looks like. So when I was walking with the golf ball and I dropped it, my walking speed, my velocity in the x direction was constant. It was the same throughout. Okay?
And how do you know it was the same throughout?
It was the same throughout because the ball, when I drop it, comes exactly back to where, when I drop the ball, it comes back to my hand.
That's right.
Now, we said that they're independent perpendicular vectors. I'm sorry.
It's easy for you to say.
Tongue-tied over here. So this vector is independent of this vector. They do not affect each other.
What happens to the vertical?
What happens to the vertical? So when you drop the ball, in the very beginning, the velocity is, well, we're going to let this arrow represent the velocity. At the very top. It's there, but it's not that big. Around the halfway point, as it's falling, you can see by my arrow, my vector here, the velocity is a little bit bigger.
Why?
The velocity is bigger due to gravity pulling it down and making it accelerate.
There you go.
Then, as we get right before it hits the bottom, it's the highest velocity we have. It bounces.
But wait a minute, that's the highest velocity, but what about the horizontal?
Again, the horizontal has not changed at all. It's constant. It bounces, and then we repeat the whole thing over again, but going back up, right? You can see right here the velocities are the same. And throughout the entire process, my velocity in the x direction, my horizontal direction is constant. It does not change.
Oh, because it's slowing down on the way up, but that horizontal stays the same. I get it.
Yep. Velocity decreasing here. And then again, we have it right how it was in the very beginning. We're back to the starting point, and the ball was in my hand.
Sweet.
The motion in one dimension is unaffected by motion in the other, as if the other didn't exist. Let's take another look at an example of this. And also look at my beautiful classroom.
Oh,
You guys haven't been in yet?
it's so clean in here. It's creepy.
It is clean. I clean a lot. Okay. All right. So this is, I asked Mr. Boykin what to call it, and he said it's a projectile motion thingy. So let me talk about what we have here.
That's thingy with an I-E.
We have two balls. This one has a hole in this end. Okay, and it will go on this side. And this one is gonna go in this little divot, little dent right there. It'll sit right there. I'm gonna go ahead and put the balls on here. Bada boom, bada bang. Okay. And there's a little air bubble at top. Can you see it? And so I'm gonna make sure it's exactly level. That's pretty much as good as it's gonna get. Okay, so what I'm gonna do is, in a moment, I'm gonna flip this switch up, and what's gonna happen is the ball on this side is going to drop. The ball on this side is going to be kicked off that way. My question for you is, which one is going to hit the ground first?
Stop and make a decision. Pause this. Make a decision.
Okay, and how will we know which one hits first? Well, we can listen. Okay, so you want to be listening for which one hits first. Are we ready?
Okay, Ms. Mo, go. I only heard one bang.
So you only heard one bang. So if we only heard one bang, what does that mean? Well, it means that they both hit at the same time.
Wow.
Whoa! Who would have thought?
That's because...
And that's because the motion in one dimension is unaffected by the motion in the other, as if they do not exist. It doesn't matter whether it has just vertical velocity or if it has horizontal and vertical velocity. The horizontal is constant. They're both going to hit the ball and fall at the same time. Okay, so how do we deal with these sorts of problems? Well, it's best if because there's two components, the x and the y component, we're going to break it up into the x and the y components using our T-chart. Every single time we have a two-dimensional projectile motion problem, we are going to be doing this, always. So a couple rules. The horizontal motion is constant. Now what does that mean again? Remember what we did over here? This horizontal motion is constant. The arrow is the same length throughout, constant motion, same motion, which means it's not accelerating. So we are going to be using this equation. And these x's just mean that it's in the the x direction. Again, I always have to think about horizontal, horizon.
Horizon is the easy one. Vertical is that other one.
Yeah, the other one.
I have the same problem.
And then the vertical motion accelerates and obeys all the kinematic equations. So when we're thinking about vertical, up and down, we're going to be using the kinematic equations. when we think about horizontal, we use this equation. You may not use this equation for vertical.
Bad student. May not use it for the vertical. Bad student.
Okay, so that's a lot of words. What does it look like? It looks like this. Write this down, and you can see the horizontal x component. Again, a reminder, x component, that's this part right here. Okay, did you guys see that? Right here.
Got it?
Okay, we're using this equation. It's constant, acceleration is 0. Constant velocity. Now, for the vertical, the up and the down, the green arrows over here. Okay, remember when we did all those problems with the balls falling, and we used the kinematics? That's where this comes into play. Acceleration is always equal to gravity, which is negative 10 meters per second. Then you have to select the equation that has, we have 4 variables, 5 variables. We have 5 variables.
5 possible variables.
5 possible variables, and whichever 4 variables you have, the variable that's missing from the equation, that's the one you choose.
Yeah.
So, my question for you. A rifle at height h above the ground fires a bullet parallel to the ground. At the same instant and at the same height, a second bullet is dropped from rest. In the absence of air resistance, which bullet strikes the ground first?
In the absence of air, everyone suffocates.
Okay, everything we know is a lie. Pause the video or write down what you think this is. And then let's go ahead and do our demo one more time to help you think about this. So we have the gun fires a bullet, and one of the bullets get in there. Oops. And one of the bullets is being shot out of the gun. It's being projectiled off that way. And then the other one is just come on, get in there. Is just being dropped from the same height though. Make sure it's level, okay? And the question is, which bullet strikes the ground first? Make sure I'm in a good spot here.
They both hit the ground at the same time, Miss Marr.
They both hit the ground at the same time.
Where did that other little feller go? Oh, there it is. Where are you?
So coming back to our original question, don't want to lose those. Coming back to our original question, the question that I asked you guys at the very beginning of class is, would it matter if you just hopped off the diving board into the water? Would you reach the water first? Or if you ran off and then if you ran off the diving board? And so the time to reach the water from a diving board is not affected by whether you run or not. You guys have seen it. It doesn't matter if it's projectiled off or just drop straight down. Because of the acceleration due to gravity, it's going to, and the constant velocity in this direction, the horizontal direction, it's going to reach the ground at the same time.
Yeah, that's right. The time is like if you're on the low dive or the high diving board, right? High diving board, you're in the air longer.
Yeah.
You're going faster when you hit the water.
Yeah, exactly. So no, it does not matter. And make sure you always use the X and the Y components, independent.
That's all, folks.